Hello, class. So today we are starting chapter 3, which is really all about polynomials, okay? So section 3.1, and we're going to start with something we kind of already know about, which is quadratic functions. Okay, so here we're going to just talk a lot about quadratic functions. So I want you to recall that a quadratic function is a function, well, it's a polynomial, okay, of degree 2. Okay, so is a poly of degree 2. Okay, and if we recall, it's like standard form is ax squared plus bx plus c. A is not 0. All right. So I also want you to recall the transformation section. So we know how to graph these things, sort of, right? So if I gave you a function like this, x plus 1 squared plus 2, right? We know that this means go left 1 and up 2, right? So we can graph this because we're like, here's the original. We go over 1, and then we go up 2. Okay? So the problem is this, though, all right? What if I asked you to graph f of x equals x squared plus 2x plus 3, right? This is the problem because you don't really know how to graph this, right? Like you don't, this 3, is that a shift? What is this x doing, right? Like this isn't how we learn to graph these. So we have to figure out how do we graph all quadratics, not just the ones that are already in this form that we know how to graph with, okay? So here's where I'm going to introduce something that I call vertex form. Okay, and it's basically the form that we know how to graph. So I'm going to put an a here, x minus h squared plus k. And if you notice, I have an hk kind of like the circle, except this time hk is the vertex. Okay, and the vertex is this middle part in the U. So this is the vertex, which is really the most important part, right? Because if you know where the vertex is, then you can just like put a U coming from it, right? So we would like it to be in this form. And then also the A tells us something, okay? If the A is positive, the parabola is up, like this picture, right? Here A is 1, so the parabola goes up like normal. But if I had like a negative number in front, then the parabola is down because, right, if we put negative numbers in front, right, that's like a reflection. So that's what this A does. It stretches, shrinks, but it also reflects. So how do we get this thing to look like this thing? All right, and the answer, which is why I told you way back ago that this is important, the answer is we have to complete the square. Okay, so hopefully you know how to do that already because we learned it. But specifically here, we have to complete the square differently, right? Because we have this f here on the left-hand side. So we kind of don't want to just add to both sides. Like that's legal, but that's a little weird, right? So I'm going to complete the square. So b is 2, b over 2 is 1, b over 2 squared is 1. So here I would normally want to add 1 to both sides. But instead, what I'm going to do is I'm going to add the 1, okay? And then I'm going to subtract the 1. And the plus 3, I don't really care. It just goes off to the side. Now, by the completing the square formula, right, this becomes x minus plus 1, right, squared. And then this is 2. So ta-da, we're done. Right now, this is in the form we know how to graph, right? Left 1 up 2. And in fact, it is this, right? So these didn't even look the same, but it turns out these are the same function. These are both f, all right? Which is maybe why I labeled it that way. Okay. So yeah, this is how we graph. Okay, so let me do one more example. Okay. So let's do x squared plus 6x plus 12. Okay, so we complete the square. So b is 6, b over 2 is 3, b over 2 squared is 9. Okay, so I'm going to add 9 and subtract 9. So plus 9 minus 9 plus 12. Okay, now this part is the complete the square part. So this becomes x plus 3 squared. Okay, and then this we just figure out. So that's gonna be plus 3. So that there we go. So if we wanted to graph this, we would go up 3 to the left 3. I almost messed up the transformation. And then it would go up. Okay. No. Let me move it over there where it's less awkward. All right, so yeah, ta-da, the graph. Okay. So just like completing the square when we like solve for functions, completing the square is a little more annoying when we actually have an a. Okay, so here I'm gonna have negative 2x squared minus 12 plus 23. No, 12x, sorry. Okay, so what we have to do first, kind of like when we were solving, is we gotta get rid of the negative 2. So we gotta do x squared plus 6x. And the 23, I'm like really gonna forget about it. Like it's just off to the side. We don't care. Okay. But then after you factor out the minus 2 and you have a 1 here, this is b. Okay, so b is 6. So b over 2 is 3. So b over 2 squared is 9. Okay. So we're going to add and subtract 9. But again, remember, you got to be careful because you have to do it inside this parenthesis. Okay, so negative 2 parentheses. Okay, so x squared plus 6x plus 9 minus 9. Okay. And then I'm gonna especially write down inside the parentheses. Okay, required. And then the 23, again, I'm just carrying it. It's off to the right. We don't care about it. We don't do stuff. Okay. Now, this is the complete the square part. So that becomes x plus 3 squared. Okay. The minus 9, we're just gonna leave it like that. And the minus 2 is like that. Okay, so you don't have to do this middle step, but like I'm gonna have to distribute this negative 2 now. So you could have done this automatically. Right, you can always skip steps if you guys want. But this becomes 18 plus 23. And then this becomes a very big number. So 18 plus 23, that's a 1. And 40? 41? Okay. So the vertex, so like this thing, right, would be at you go 3 to the left, you go 41 up, and the negative sign means we would go down. And the 2 technically means we like stretch it by 2, but like no one cares, okay? All right. Now I want to show you one more example of this. Okay, so there's another way to get the vertex, right? Because from here we can see the vertex, right? The vertex would be negative 3, 41. Okay, but let's do another example. So I'm gonna have kind of a similar function. So 2x squared minus 12x plus 23. Okay, this one's gonna be nicer though. But let's pretend I don't want a graph. Like literally the question is, what's the vertex? What's the vertex? Okay, if the question is what's the vertex, then you can do what we just did, right? We can complete the square and you'll get the vertex. That's not a problem. But there is a faster way to do it, okay? And it's with this formula, okay? So the formula is h, right, which we know is the x coordinate of the vertex, right? H, if your parabola is in standard form, is going to be equal to negative b over 2a, okay? So I know a lot of students like memorizing this formula and doing it this way, so I'm going to highlight it. But yeah, that's h, and then k is just going to be plug in h, like whatever you get, okay? So it's going to be f of negative b over 2a. All right, but so let's figure that out. H equals negative b, so that's going to be 12, over 2a, so 2 times 2, I'm going to write that down. Okay, so 12 over 4, so that's going to get you 3. And then k is going to be f of 3, which, you know, just plug in, and you're going to get numbers. Okay, so that's going to be 9, 18, minus 12 times 3. What is that? That's going to be 6, 36, I hope, plus 23. Smash that into a calculator, and let's hope that's 5. Okay. And yeah, ta-da. So this, the vertex. The vertex is 3 comma 5. All right, so you don't have to complete the square. If the question is just find the vertex, ta-da. Okay. And actually, if I wanted to, I can put this in vertex form now, because right, I know h and k, right? H and k, and a is actually just a. So a here is 2, right? That's what we plugged in. So f here would actually be 2x minus 3 squared plus 5. So this is this parabola in vertex form. And it's kind of like cheating, but you're allowed to do it if you use this formula, okay? So I know a lot of students like doing this. You feel free to do it this way if you like it this way more. But this relates to the like word problems in this section, okay? So, not example, I have to talk about them. So, in the section in chapter 2, I don't remember, but we learned about increasing, decreasing, maxes, mins, all that kind of stuff. Okay, so we're going to specifically talk about parabolas right now. Okay, so if we have a parabola, then you notice, okay, the vertex is always going to be the max or the min. All right, and specifically, it depends on what A is. Okay, so if A is positive, then you're going to have a minimum, and the minimum value is going to be f of h, which is equal to k. Okay, but if your parabola is upside down, right, if a is negative, then you have a max value. And that's still going to be your vertex, which is going to be k. All right? So now you can answer questions like this, which all questions in this section, like even the word problems and stuff, all of them basically mean in math language, find the vertex. Okay, so if you're kind of confused on a word problem in like this section, the answer 90-something% of the time will be find the vertex. Okay, so the question here is, what is the max slash min value? Okay, and so here's our function, f of x equals 2x squared plus 4x minus 5. Okay, so first, you notice a is positive, so that means we're going to have a min, right? Because our parabola looks like a regular U-shaped, right? So we're going to have a min. So then I'm just going to use the formula I just showed you, right? So h is negative b over 2a, which that's going to be negative 4 divided by 2 times 2, which that's going to be negative 1. Okay, so f of negative 1 is going to be 2, negative 1 squared, negative 1 minus 5. 2 minus 4 minus 5 equals negative 7. So, okay, here's where you got to be a little careful because some professors are very mean, right? I'm asking for the max or the min value. So technically, you should say something like the minimum value is negative 7, okay? And then if you want to be nice, you can be like at x equals negative 1, okay? But you should not say the minimum value is negative 1, negative 7. That's the minimum, not the minimum value, okay? So whenever you see the word value, remember that's like the what you are, that's the y coordinate. Wherever you see where, right, if you're asking like location, that's the x coordinate. And then if I just say min max, that means I want the whole point, right? So I want the x comma y stuff. Okay. Well, let's do a couple of these. So find max slash min for, and then here's a function, g of x equals negative x squared plus 3x minus 4. Okay. Right. You have the handy dandy negative b over 2a. You plug in, so 2 times negative 1. So that's going to be 3 over 2, right? Because the negatives cancel. So h is 3 over 2, which is a little nasty, but that's okay. You guys are adults. You can handle fractions. I believe in you. All right. 3 over 2 minus 4. This is actually a little nasty. 9 over 4 plus 9 over 2 minus 4. Let's do some fraction math here. So that's going to be 18 over 4 minus 4, which that's going to be 9 over 4 minus, so 4 is 16 over 4, which we get the final answer to be negative 5. Am I going insane? Negative 5 over 4? 9 minus 16. So 10 minus 16 would be negative 6. I add 1. Is it negative 7? Have I gone insane? Negative 7? How does one subtract? I have forgotten. please excuse me while I remember how to subtract. All right, it's always good to double check, you guys. All right, so yes, it's -7. I went crazy there for a minute. Excuse me. All right, but yeah, so the max, find the max. So, okay, so first of all, I didn't even say anything, right? So that's a -a, right? A is negative because it's -1, right? So that means we do have a max because the parabola is upside down, okay? So the max is 3/2, comma, -7/4. Okay, so a little messy, but you know, you guys can do it, right? Now, let's do some word problems, okay? So I'm just gonna do one because again, I told you the secret, okay? The secret, let me write down the secret, okay? So all of the word problems in this section, right? In this section, all right, all of them just mean find the vertex, okay? It doesn't matter if you want to like maximize the area of a cubicle, if you want to find the best MPG of a car, if you want to find the maximum height of a football being thrown, or the minimum of an energy of a house drawn, okay? All of the word problems just mean find the maximum. Or no, find the vertex, my bad. Which could be the min or the max. Okay, so I'm gonna write down this pretty long word problem, okay, but most cars get their best gas mileage, okay, mileage when traveling at a modest speed. Okay, so like this is like actually a real problem, right? We all know highway MPG greater than city MPG. But this word problem is about to be expired, right? Because we're all going electric soon. Yes? Are you guys laughing at me? Okay, no, I'm just kidding. So the gas mileage M, all right, is modeled by the function. All right, and then here's they're gonna give you the function, okay? -1/28s squared plus 3s minus this. All right. What is the best MPG and what speed gets that? Okay. So let's go through the word problem again. Okay, so modest speed M modeled by, okay, so we have the parabola, right? We know this is a quadratic equation, okay? And we're doing gas mileage, okay? So first of all, I mean, you don't even need to read the word problem, but we're gonna find the max, okay? But something that's important though is that this thing is speed, right? S. So we really are gonna think of speed being greater than or equal to 0. Okay, because we don't like, right, like we're not considering negative speed, right? This is the one word problem part that's interesting, right? Is that speed is positive, okay? But besides that, we're just gonna, you know, slap it in the formula. So H is equal to -b/2a, which is gonna be -b, so -3/2a, so negative this. The negatives cancel. And just in case you're a little confused about the 28 being a fraction, I'm going to multiply 28 on the top and the bottom, so that cancels. So you get 3 times 28 divided by 2, which is actually 3 times 14, which is actually 42, okay? Or you can just punch it in the calculator. But the answer is 42. So, the speed that gets you the fastest or the best MPG is going to be 42 miles per hour. And now, to figure out what the best MPG is, we just need to plug it into our formula. So M of 42 is going to be 28. 42 squared plus 3 times 42 minus 31. And then here's the disclaimer of definitely for a word problem with nasty numbers, which I hope I didn't ask you on homework, but like definitely on the test, the numbers will be nice enough. But just punch this into your calculator, okay? So 42 squared plus 3 times 42. Okay, if you crunch that all out, it does magically become 32. Okay, so the best MPG of this car will be 32 miles per gallon. Okay, so again, this is a word problem. So you definitely want to double check your units are correct. That's like the one annoying thing that you could get wrong is you can do all of this, but if you don't really understand, you might mislabel the units. Okay, but again, that's the only word problem I'm gonna cover. All right, but remember the secret. Okay, all of the word problems in this section, all right, what they all are just asking you to do is find the vertex. Okay. All right, but that's it for section 3.1. All right, we're starting the polynomial section. Okay, so we started off with quadratics. So now you should pretty much know everything there is to know about a quadratic, right? You can graph them no matter what it looks like by completing the square, hopefully. And then you can put them in vertex form, either by this magic formula, h equals negative b over 2a, or by completing the square. All right, but that's it for this section. See you guys in the next section.